class 12th students. Here we are going to start our third part of the chapter solution, that is solubility. In this chapter we will discuss about the solubility of solids and gases in liquids and the factors affecting the solubility. Now let us start with the definition of solubility. What is solubility? Solubility means ability. The ability to dissolve solute particle is called solubility. What does it mean? Solubility means ability. The ability to dissolve solute particle is called solubility. Now let's see the proper definition of solubility. Solubility of a substance is its maximum amount that can be dissolved in a specific amount of solvent at a specified temperature. Solubility of any substance is its maximum amount that can be dissolved in a specified amount of solvent at a specified temperature. It means for solubility, the amount of solute should be maximum in which the amount of solvent should be maximum in which the particular solute gets dissolved, and conditions for dissolving the solute in a solvent, the temperature should be specified. Only then the solute can properly dissolve or properly soluble in a solvent. Now let us take an example. Suppose in a classroom there are 40 seats and you can add only 40 students to it. There are 40 seats in a classroom and you have to add, or you could add only 40 students to it. Not more than 40 students can be added to that classroom. What does it mean? It means when maximum amount of solvent is there, means maximum amount of seats are there, it means only a maximum amount of solute can be added to that solvent. It means if you have 40 seats in a classroom, then you can only add 40 students at a time in that classroom. You can't add 41 students to that classroom. Then the accumulation of students in a classroom gets crowded. Same will happen with the solute and solvent. If more solute is added to the solvent, when solvent can't accumulate the solute more than its enough tendency to accumulate a solute, then the solute will not get dissolved in the solvent. So what is solubility? Solubility is the ability of a solvent to dissolve solute particle. That ability should be maximum to dissolve maximum amount of solute particle in a solvent. This is known as solubility. Now the solubility factors, solubility depends upon the following factors. What are these factors? Let's see. Solubility depends upon nature of solute. The solute which is added to the solvent, that solute should be verified with solute. And solubility depends upon nature of solvent as well. Solubility depends upon both nature of solute and nature of solvent. Solubility depends upon temperature and also solubility depends upon pressure. Now these are the factors in which solubility of solids as well as solubility of gases in liquid depends upon. These are the factors. Now come to the next topic, that is solubility of solids in liquids. We will start with the solubility of solids in liquids. Now the solubility of solids in liquids also depends upon these factors which we have discussed earlier in our previous slide. First factor of affecting solubility of solids in liquid is nature of solute and solvent. Let's see, when a solute is added to the solvent, when a solid solute is added to the solvent, some solute dissolves and its concentration increases in the solution. This process is known as dissolution. Okay? To understand the process of dissolution, let us take an example. Suppose you have a glass of water. Suppose you have a glass of water, and in the glass of water you are adding some sugar molecule to that glass of water. Sugar, or you can take salt as well. You are adding some sugar particles or some sugar molecules to that glass of water. When you are adding sugar molecules, what will happen? Then that solute particle or that sugar particle gets start disperse in the solvent part. They will get start disperse in solvent part, and they will increase the concentration of solute particle in solute. As you are adding sugar to water, the concentration of solute will increases. As you are adding sugar, the concentration increases slowly, and as the concentration increases, the dispersion of solute takes place. The dissolution or the dispersion or the dissolution of solute takes place. So that process, when dissolution takes place, when dispersion of solute takes place, is known as dissolution process. Now after dissolution, what happens? When a solute particle get dispersed in the solution, after dissolution or after dispersion, what will happen? When some solute particles, now come to the next, when some solute particles in the solution collide with the other solid particles and get separated out in the solution, then this process is known as crystallization. Now what is crystallization? After dispersion of solute particle in the solvent, when some solute particles in the solution collide, when collision of solute particle takes place, when some solute particle in the solution gets collide with other solid particles, then they will separate out in the solution. Then some solid particles will get separate out in the solution. Okay? And that separation process is known as crystallization. Means a crystal gets separate out. This process is known as crystallization. Now a stage is reached when two processes occur at the same rate. And after getting crystallized, a state is reached when the two processes occur at the same time. Under such condition, number of solute particles going into solution will be equal to number of particles separating out and a state of dynamic equilibrium reached. It means the number of solute particle you are adding equal to the number of particle which will get separate out and which will get crystallized. Both the process and both have same rate, and that process and that state is known as dynamic equilibrium. It means an equilibrium established between two processes, between dissolution when you are adding solute and when solute particle collides and make a crystallization process. So the equilibrium established between two processes, between dissolution and crystallization, there is an equilibrium, and that equilibrium is in a dynamic state. At that time, the formation of solution takes place. When dissolution and crystallization are in equilibrium, then formation of a solution takes place. It means on adding solute to the solvent and the equilibrium state is reached, then they form a solution. This is the nature of solute and solvent. It means for such type of processes, one word that everyone should be in mind, that like dissolves in like. It means the nature of solute is similar as the nature of solvent have. If your solute molecule is polar, then that must be soluble with the solvent having polar nature. And if your solute particles are non-polar, it means your solute particle will get soluble in such solvents which are already non-polar in nature. They will not get soluble or dissolved in such solvent which are polar in nature. It means this will work on the phenomena of like dissolves in like. Suppose you have salt and a sugar as a solute particles and you are adding salt and sugar to water molecule, they will easily get soluble in water molecule. Why? Because salt and sugar both are polar in nature and water is a polar solvent. And polar solute particles have a tendency to get soluble in polar solvent molecule, that is water. That's why salt can easily be soluble in water due to the polar nature. But if you want to soluble salt in a non-polar solvent like benzene, carbon tetrachloride, any other non-polar solvent, so at that time the polar salt NaCl, sodium chloride, will not soluble in that non-polar solvent. Why? Because like always dissolves in like. And for to dissolve any solute to non-polar solvent, we have to dissolve non-polar solute to non-polar solvent. This is all about nature of solute and solvent. Now come to the next factor, that is effect of temperature. Now what is the effect of temperature when a solid gets soluble in a liquid? Now this can be explained whenever there is a disturbance in equilibrium. Whenever there is any disturbance in equilibrium, then equilibrium can shift in the direction to reduce the effect of change, according to Le Chatelier's principle. Now, the temperature has a marked effect on the solubility of solid in solvent. Temperature has marked effect on the solubility of solid in solvent. The solubility may increase or decrease with increase in temperature. This is important. The solubility may increase or decrease with increase in temperature. Now, from this, we observe three types of trends in the behavior of different solute. Suppose suppose we have the solutes. When such type of solutes are there, the solubility of solute increases with increase in temperature. It will depend on the nature of solute, which type of solute you are adding to the solvent. It will depend. Effect of temperature depends on the nature of solute which you are adding to the solvent for making a solution. Suppose first point, the solubility of solute increases with increase in temperature. What type of solutes? Which on adding solutes the temperature gets in, solubility gets increases on increasing the temperature. Let's see the solubility of most of the substances such as sodium nitrate, ammonium chloride, potassium chloride, silver nitrate, potassium iodide, etc. increases with rise in temperature. Why increases? This is because, this is important, this is because dissolution process of these substances is endothermic. It depends upon the dissolution process. What type of dissolution process is there? This is because of the dissolution process of these substances, because their dissolution process is endothermic in nature. It means the heat release during the solubility during the mixing or during on adding the solute to the liquids, the heat release during mixing and the value of delta H is greater than 0. It means the process is endothermic. When the process is endothermic, then on increasing temperature solubility will also get increase according to Le-Chatelier's principle. Now come to the second point. Some solutes are also there. On adding those solute, the on increasing some solutes are also there. On increasing the temperature, the solubility of such type of solute gets decreases. Now let's see which type of solutes are there. The solubility of some substances like lithium sulfate, cerium sulfate, and some calcium salts of organic acids decreases with rise in temperature. Why? This is why. This is because their dissolution process is exothermic. Why this is? This is why because their dissolution process, when such type of solute particles get dissolved in liquid, they dissolve in by exothermic process. They dissolve by exothermic process. In this process, the value of delta H is negative. Now come to the third point. What is the third point? The solubility shows irregular behavior with temperature. There are many other substances which shows irregular behavior with increase in temperature. We have discussed about two type of the substances, which are some are the some of the solute particles gets their solubility increases with rise in temperature because their dissolution process are endothermic. Some of the solutes are also there, their solubility decreases or increasing the temperature because why? Because their dissolution process are exothermic. But there are some of the other solutes are also present in which their solubility shows irregular behavior with increase in temperature. Now let's see with an example. The solubility of sodium sulfate increases up to a certain temperature and then decrease as the temperature further raises. This is the irregular behavior. The solubility of sodium sulfate increases up to a certain temperature and then decrease as the temperature gets raised. The break in the solubility curve is known as transition temperature. The break in that solubility curve is known as transition temperature. Now let's see with the help of graph. This is the first point. For such type of solute, on adding to liquid, on adding to solvents, their dissolution process is endothermic and the solubility gets increases on increasing the temperature. These are the substances. This is solubility versus temperature curve. On increasing temperature, solubility of AgNO3, solubility of Ki increases because their dissolution is endothermic in nature. Solubility of ammonium chloride, solubility of potassium chloride gets increases or increasing the temperature because their dissolution process is endothermic in nature. Now come to the second point. Such type of solute dissolves with evolution of heat where the process is exothermic. Process is exothermic means when solute is added to solvent, their dissolution process is exothermic because heat gets evolved. Value of delta H less than 0, value of delta H gets negative. So such type of solute are also there which shows downward curve, means on increasing temperature their solubility gets decreases. You can see lithium sulfate solubility of on increasing the temperature the solubility of lithium sulfate gets decreased. Now come to the third type of this condition. there are also some solute present which shows irregular behavior on increasing the temperature. Irregular behavior of solubility on increasing the temperature. Now, curve of Na2SO4, curve of sodium sulfate. In the curve of sodium sulfate, initially you can see initially on increasing the temperature, the curve of sodium sulfate, the solubility curve of sodium sulfate gets increases. But at a certain point, at a certain temperature, and what is this time and what is the temperature? The temperature is 32.8 degrees Celsius. At 32.8 degrees Celsius, there is a point where the break of the curve starts. And that point from where the break of the curve start is called transition temperature. Here at 32.8 degrees Celsius, the solubility of Na2SO4 after this or after 32.8 degrees Celsius temperature, on increasing further temperature, the solubility of Na2SO4 gets decreases. This is the irregular behavior of solubility when temperature is increases. Now, below 32.8 degrees Celsius, only sodium sulfate decahydrate exists. Na2CO4.10H2O. It means sodium sulfate in its crystalline form can exist below 32.8 degree, below this line. Here sodium sulfate decahydrate can exist, but above this temperature anhydrous Na2SO4 exists. After breaking of the curve above this temperature, above 32.8 degree, only Na2SO4 in anhydrous state can exist. So this is the effect of temperature of solids in liquids. This can be shown by three type of the effect. One, when the solute dissolves, when the process of dissolution of solute is endothermic, means adsorption of heat, then the solubility of solid increases on increasing the temperature. Second, when the dissolution process of solute is exothermic, means evolution of heat, the solubility decreases with increase in temperature. And the third point, the irregular behavior of solubility on increasing the temperature. Where a point came where the break of the curve begins, that point is known as transition temperature. Now come to the next part. Effect of pressure. When solid is added to the liquid, what is the effect of pressure? Now, the pressure does not have any significant effect on solubility of solids in liquids. There is no significant effect of pressure on solubility of solids in liquids. Why? This is because solids and liquids are highly incompressible. Neither solid nor a liquid can be compressed. They both have a property, solid and liquid have a property that neither a solid nor a liquid can get compressed. That's why there is no significant effect of solubility of solids in liquids, because we can't apply pressure to compress solid for dissolution of solid in liquid. And liquids are highly incompressible and practically remain unaffected by the change in pressure. Suppose you have a liquid and you have to add solid in liquid. By applying pressure, you are adding solid in liquid and you are changing the pressure. On applying pressure, there is no effect of pressure or when you are adding solid in liquid. Why? Because solid and liquid both are incompressible. They does not affect pressure on adding solid into liquid. Now come to the next part. Next is solubility of gases in liquids. As we have discussed the solubility of solids in liquids, now the turn of gas solubility of gases in liquids. Similar factors affect the solubility of gases in liquids. First of all, gases dissolves in liquid to form a homogeneous solution. It means to form a uniform solution. Let's start with effect of temperature. What is the effect of temperature when we are going to study or going to discuss about solubility of gases in liquids? Now, all the aquatic life can only survive due to the dissolution of oxygen in water. Oxygen is a gas and it is dissolved in water, means dissolution of a gas in liquid. That's why only the aquatic life can survive. Now let's see the effect. What are the effects of temperature, pressure when the gas is adding to the liquid? Let's see effect of temperature. The solubility of the gas decreases with increase of temperature. This is important. The solubility of gas decreases with increase of temperature. Why? This is because the gas is dissolved in liquid with the evolution of heat. The process by which the gas dissolved in liquid is known as exothermic process. Gas is always dissolved in liquid by the process. That process is known as exothermic process. That's why on increasing the temperature, the solubility of gas decreases. This we have already discussed in the solubility of solids in liquid. Some solids are also there, some solid particles are also present, which shows when dissolution of solid in liquid takes place, that they shows the dissolution process by evolution of heat. It means their process is exothermic. Similar case in liquid, when all the gases dissolves in liquid, they dissolve with the evolution of heat. They dissolve in liquid by the evolution of heat, and when the heat evolves, that process is known as exothermic process. That's why on increasing the temperature, the solubility of gas decreases in liquids. Now, according to Le Chatelier's principle, the increase in temperature will result in decrease in the solubility of gas, because any disturbance in temperature, any disturbance in equilibrium, then the equilibrium will shift in that direction where to reduce the effect of change. This is Le Chatelier's principle. Now, if temperature is increases, then solubility of gas will get decreased, because process तो क्या हो रहा है हमारे पास exothermic means evolution of heat. अगर evolution of heat वहां हो रहा है तो process exothermic है. उस इक्विलिब्रियम को चेंज का हमने टेम्परेचर इंक्रीज कर लिया. अगर हम टेम्परेचर को इंक्रीज कर रहे हैं तो उस प्रोसेस का अपोज करने के लिए, ताकि वो अपनी स्टेबल पोजीशन में आ जाए, जो इफेक्ट हुआ है चेंज में उसको रिड्यूस कर दे, तो Le Chatelier's principle is applying there, and due to Le Chatelier's principle, the temperature on increasing temperature, the solubility gets decreases. Now, this can be seen by an example. Fish, aquatic life. On increasing the temperature, the aquatic life. On increasing the temperature, the fishes dies in seawater. Why this is so? On increasing the temperature, with rise in temperature, the solubility of oxygen gas decreases. That's why this happens. On increasing the temperature, the aquatic life die. Why? This is because as the temperature increases, the solubility of gas in seawater the solubility of gas in seawater. Which gas is soluble in seawater? Oxygen. The solubility of that oxygen gas in seawater will get decrease, and as the solubility get decreased, they can't get enough oxygen to survive. That's why they died when temperature gets increased. Now there is some exceptional cases also for hydrogen and inert gases. When hydrogen and some inert gases added to added to liquid, on increasing temperature, their solubility also get increases. Now come to the next effect of pressure. The solubility of gases increases with increase of pressure. This is the point. Solubility of gases increases with increase of pressure. But in case of solid, there is no significant effect of pressure when solid is added to the solvent. But in case of gases, solubility of gases increases with increase in pressure. This is the difference. Why? Because gas is compressible in nature. Gas has a compressibility factor. This can be seen by the example. This is diagram A and this is diagram B. Suppose in diagram A, in a beaker, you have a liquid. This is liquid part and this is a gas part. This is gas part here. Now this above the gas, a piston is put it here above the gas. On and a weight is put over the piston. This W1 is a weight which is put over the piston. Now on applying pressure, when we put the weight over the piston, then the gas will compress, slightly compress to the liquid, because gas has a tendency to compress. So gas will slightly compress. Now if we add 2 more weight over the piston, if we add 2 more weight, now there are 3 weights over the piston. Now what will happen? The piston will move downward. In this image, this can be clearly shown. The piston moves downward up to half. Why? Because as we increase the pressure, the gas slowly gets soluble to the liquid. Because pressure is directly proportional to solubility, means on applying pressure, the gas easily soluble with liquid. Here we have only one weight over the piston. The gas will compress, but in a very slight rate. But on applying 2 more weights on over the piston, then the piston will move up to half of the beaker. And the gas will compress and easily get soluble with water. एक बीकर था, उस बीकर में वाटर रखा हुआ है, उसके जो बॉटम पार्ट है वहां पे वाटर है और वाटर के ऊपर कुछ गैस प्रेजेंट है. उस गैस के ऊपर हमने एक पिस्टन रखा. उस मूवेबल पिस्टन है, उस मूवेबल पिस्टन के ऊपर हमने कुछ वेट उसे प्रोवाइड करा जिससे कि उसे प्रेशर आए और प्रेशर के थ्रू वो जो मूवेबल पिस्टन है वो मूव करना स्टार्ट करे डाउनवर्ड डायरेक्शन में. नाउ व्हाट विल हैपन? That movable piston will move slightly. If weight is 1, then that movable piston will move slightly. If we increases the weight, in second picture, we increases the weight from 1 to 3. We have 3 boxes over the piston, W1, W2 and W3. Now what will happen? That piston will move up to half of the beaker. This can be easily shown by this figure. The piston moves up to half of the beaker. What does it mean? It means the gas compresses and it gets soluble with liquid. It means on increasing the pressure, the gas is easily soluble with liquid. So this is pressure. This is why pressure is directly proportional to solubility of a gas. This is all about today's video. Now in next video we will talk about the law. The effect of pressure has a law, and that law is known as Henry's law. when solubility of gas increases with increase in temperature. This law is known as Henry's law. This will be discussed in our next video. Thank you.